How do we measure changes in the mass of the ocean? If we can measure the pressure at the bottom of the ocean, that will tell us about the mass of the column of water and atmosphere above. Changes in this mass are due to the tides caused by the moon and the sun, ocean currents or so-called ocean weather, and the water entering the oceans from melting ice sheets. The ocean is over 4 kilometers deep in places, so how do we go about measuring changes in pressure on the ocean bottom? Ocean bottom pressure changes vary widely from place to place, and therefore we need to measure it in many locations. Ships capable of deploying bottom pressure recorders, or BPRs, carry them to sites specially chosen to record measurements for specific purposes. BPRs are tough and self-sufficient instruments. While there are different designs, many have common elements. The most important part is a pressure sensor containing a quartz crystal whose vibrations change due to variations in pressure and temperature. As BPRs can be in the ocean for over 2 years, a large number of batteries are needed to power the electronics. Capsules that record the data can then be released remotely when the ship returns. Descending to great depths can take a long time. As the BPR sinks to the bottom, the pressure greatly increases. It takes about 45 minutes to descend to a 4-kilometer depth. The pressure on the bottom is 400 times greater than what the ship experiences at the surface of the ocean due to the atmosphere. Some bottom pressure recorders can detect changes in sea level of 1 centimeter even from depths of 4 kilometers. Sea level is influenced at different timescales. The tides continually change sea level over periods of hours. Long-term changes in average sea level are calculated by removing the tidal effect during data analysis. On shorter timescales of minutes, some bottom pressure recorders are used as early warning systems to detect tsunamis. While early deployments of bottom pressure recorders were mainly used to learn about tides and ocean currents or the ocean weather, many of the long-term deployments today are used in tsunami warning systems, which is why many are located along the edges of the ocean basins. More recently, satellites have also been used to measure changes in ocean mass. The satellites of the Gravity Recovery and Climate Experiment orbit 400 kilometers above Earth's surface. Due to this distance from the Earth and the time it takes to pass over all areas of the ocean, these satellites can only tell us about the average mass changes over large areas, hundreds of kilometers, and over longer periods of time of around a month. Both the BPR and the satellite measurements tell us much about the mass changes in the ocean. In the final video of the series, we explain how these measurements tell us about how water moves between the oceans and the continents.